Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to count a shelf space using a computer vision. We can say using OpenCV. But before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, we are going to count here empty space for a shelf. So for that we need Python OpenCV. This is Windows 11 machine. Of course you can use your Windows 10 machine also. So let's just open Thony Python IDE. Thony, click on open and go to the tools, manage packages, search for OpenCV-Python, enter first package, click on install. It will install our package. Then we need here CV zone package, hit enter. Then as you can see CV zone, click on CV zone, click on install and it will install CV zone package. Done. We have done with package installation. So for today's session I have created a repository shelf space detection. So I will mention the link. You need to simply copy and paste the link inside the browser. Then go to the code, click on download zip and it will download our zip format repository. So if I open downloads, as you can see, this is what our repository. Right click, WinRAR and extract to the folder name. Then go to the inside folder, same folder again, and let's just first watch our video, then we will get the idea. So friends, this is what our video file, we can say this is what our scenario, and here it is. As you can see, we have here shelf and inside that shelf we have some products. Okay, right now shelf is full, means there is no space inside this shelf. But if I skip some frames, as you can see, and now there is a space. Here we can see there is a space. When we start our frame at the starting point, there is no space. There is no space, but when the person took out one product from the shelf, and then we have a space, or we can say we want to count this space. So for that we are going to use here our OpenCV program. So let's just start. I hope you all clear with our scenario. So now let's just open our test.py with our Thony Python IDE. So click on test.py and it will open our file, our Python code inside our Thony Python programmer. So now import CV2, a basic code cap is equal to CV2.video capture. This is what our video file. Then we have here mouse event function. When we move our cursor on the frame, we have XY coordinates of that point. So for that we mention here our mouse event. Then the CV2.name window, this is the window name, and then CV2.set mouse callback RGB. This is how we call our mouse function, mouse event function. Then the basic code for reading our video frame. Simple. So if I start the code, and as you can see the frame is right now freeze. So let's just mention here 100 wait key, and if I start the code, and as you can see our frame is started. So what we are going to do, we want to create here a counter for this shelf empty space. For that we want to draw a rectangle on each product, and we want to crop each product, and then we want to measure each crop rectangle. Inside that we have product. We want to measure, or we can say we want to count the pixel, because when there is empty space, of course there is a changes in pixel. So somehow we want to count the pixel. For that what we want to do here, we want to draw a rectangle on each product. So let's just draw a rectangle. So as you can see, when I have moved the mouse on the frame, there is a points inside our shell. So let's just say if I want to draw a rectangle on this bottle, so let's just move your mouse over here. For drawing rectangle we need top left corner point and bottom right corner point. So if I want to draw a rectangle over here on this bottle, so top left corner is basically this. So if I move my mouse cursor over here, inside shell we have 432, 195, 432, 195. So let's just mention here 432 and 195. This is what our rectangle top left corner coordinate. Then we need a rectangle bottom right corner. Bottom, first we mention rectangle top left corner point. Now we want to mention here a rectangle bottom right corner. Okay, so bottom right corner, if I move my cursor over here, inside shell we have coordinates which is 498, 384, 498 and 384. That's it. Just save the code and stop our code. So we have now rectangle coordinate. Simply we can draw the rectangle with the help of these 4 coordinates, which is basically a rectangle top left corner and the rectangle bottom right corner. So where we have our resize frame, let's say cv2 dot rectangle, cv2 dot rectangle, and inside that we want to mention where we want to draw our rectangle. We want to draw our rectangle on the frame. Then we want to mention top left corner, so 432, 195. Then we want to mention bottom right corner which is 498 and 384. Then we want to mention here a color 00255 and the thickness, let's say 2. So now just save the code and run the code. As you can see, there is a rectangle on this bottle. So we draw only one rectangle. So we want to draw a rectangle on each product. So what we are going to do, we are going to make this process automatic with the help of our mouse event function. So right now we have mouse event function for mouse moving. When we move our mouse on the frame, we have xy coordinates. But what we are going to do, we are going to create here L button down mouse event function for getting the xy coordinates. Means when we press our mouse left button, then we have that particular point xy coordinates. For that we are going to create a new function for mouse event. So let's just stop our code, and this is the mouse event move function. Right now we don't want the function. Now there is no need of this function, so we are going to simply comment this cv2 name window and set mouse callback, and here we want to mention, because we are not going to use this window, so we want to mention our new window name which is, let's say, frame. That's it. Now simply we want to create our new function, so let's just say def draw rect. This is what our function name, def draw rect. We are going to draw a rectangle. So inside that same way we want to mention this object. Just copy it and just paste it. That's it. And then again we want to mention our event, so just copy it and just paste it. Only what we are going to change here, as I mentioned, we want our mouse left button down event. So we want to simply change the mouse move, means when we move our mouse, in that time we will get our xy coordinates. We are going to now simply change L button down, means when we press our mouse left button, then we have xy coordinates. So mouse move change with L button down, simple. Then what we want? We want here our xy, print this xy. So let's just mention x and y. So if I save the code, if I run the code, now if you press your mouse left button anywhere in the frame, you will get the coordinates of that particular point. So let's just press mouse left button. Oh, we forget to call our cv2 set mouse callback function. That's why the function, function is not working because we need to call a set mouse callback, then we need to mention our function. So just copy it, the set mouse callback, and where we have CO2 im show method, just paste it, and we want to change our window name. So our window name is this frame and our function name is drawRect. Copy it and just paste over here. That's it, like this way. Now it will work. So start our code. Now if we press our mouse left button anywhere on the frame, as you can see, we have XY coordinates. If you go here, as you can see, 601156, for this point we have 601156 XY coordinates. That's it. So now we have coordinates. Now we want to draw here a rectangle with the help of our points. For that we want to create a list, and then the list which we are going to call with the help of for loop. So for that, first we want to save our XY coordinates inside the list. So let's just create here a list. The list name, you can mention any list name. I just mention here points. I have just mentioned the points. This is just a list name. Points is equal to empty list, and then now we know what we have inside our XY. So simply we need to mention points dot append, and inside that we want to create XY coordinates as a list. Now it will save, or we can say it will append our XY coordinates inside the points. Now there is no need to draw a rectangle with the help of single coordinates. First let me mention one more thing here. As I mentioned, we are going to draw a rectangle automatic, but we are going to draw a rectangle automatic on each product in same width and height, same size. We want to draw a rectangle same size. For that we want to mention fixed width and fixed height of our rectangle. So first we want to mention a fixed width and fixed height for drawing rectangle using mouse event function. So here, this is what our coordinates. With the help of these coordinates, we are drawing right now a single rectangle. So we are going to use these coordinates for our width and height. So W and H is just a variable, is equal to, just open your calculator, and then we want to 498 minus width 432. We will get the width. So 498 minus 432, we will get the width, which is 66. So mention here 66. This is what our fixed width for drawing rectangle using our drawRect event function, where we have L button down function. So width is basically 66. Now we want our height. So 384 minus width 195, we will get the height. So 384 minus 195, and then we have the height, which is 189. So how do we get the width and height? Simply with the help of these coordinates, we are drawing our rectangle, only one rectangle. So if we want to draw a fixed size rectangle, we want to mention fixed width and height for drawing a fixed size rectangle. So simply we want to minus 498 inside 432 for the width, then we want to minus 384 inside 195, we will get the height. That's it. Now we have width and height. Now we can simply comment the rectangle method, and now we can call our points, because we are saving our points inside our points list. So for PTS in our points list, for PTS in points, now if we print here PTS, if I save the code, if I run the code, now if you press L button from your mouse, as you can see, we have the mouse coordinates. Simple. So now we need here let's say PTS 0. So PTS 0 will print only one index, means this is the 0 index and this is the 1 index, this is the x and this is the y for drawing rectangle. So 0, if I mention 0, it will print only x coordinates. So if I start the code, as you can see, now it's only printing the x coordinates because we mention here 0. So if you mention here 1, it will print a y coordinates. As you can see, now it's printing the y coordinates. That's it. Now we know what we have inside the PTS and how we get our x and y coordinates. Simply 0 for x and 1 for y. This is the index. So CV2 dot rectangle, CV2 dot rectangle, where we want to draw our rectangle. We want to draw our rectangle on our frame. Then mention the PTS, this PTS, then comma and then simple bracket, again mention PTS. From PTS, index value 0 for x plus our width, with this which we mentioned 66 plus our width. Then we want to mention comma, again PTS and then 1 for y plus our height, which is 189. And then we want to mention color 00255, let's mention red, and the thickness 2. So if I save the code, if I run the code, and now if you press L button from your mouse, let's just say here, as you can see, there is a rectangle. Here there is a rectangle, here there is a rectangle. You need to simply move your mouse where you want to draw the rectangle. It will draw the rectangle, same size rectangle, here also, here also, here, 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 then here and here. So as you can see, with the help of mouse event L button down function, we can automate this rectangle process. Now we successfully draw a rectangle using L button down, means the mouse left click. Simple. Now we draw a rectangle on each object. Now let's just stop the code and start the code. There is no rectangle. There is no rectangle. So now what we want here, when we start our frame, we want our rectangle on our object. So somehow we want to save our rectangle coordinates. So for that we are going to use here pickle module. So let's just create our pickle module. So import pickle. It will create a file inside our same repository, and we are going to dump our all rectangle coordinates inside that file. Simple. So where we have our points here, simply here we import our pickle. So now we want to call here our file. We want to create a file. So let's just say with open, and this will start from here. With open, we want to open a file name. So let's just create a file name. Let's say shelf. Okay, this is what our file name, which we are going to create, and inside that shelf file we are going to save our points, our rectangle points. And then we want to mention WB for write. Okay, if you want to write the file, we want to mention WB, this is the permission, and as F. Then we want to mention our pickle dot dump, and what we want to dump? We want to dump our points. So points and our file name, which is F, because we mention all these things as F. Now it will create our file. So let's just save the code and start the code. If I press L button, as you can see, we create a rectangle, and if you open your repository, inside that, as you can see, we have now shelf file. So inside this file we are saving the coordinates, but we save the coordinates, we draw a rectangle, but right now, as you can see, there is no rectangle. Let's say if I draw a rectangle over here, and if I stop the code and if I start the code, there is no rectangle. Why? Because when we start our code, in that time there is no point. So we want to call our file when we start our code. We create the file with the help of Pickle. So we want to call that file when we start our code. So let's say here, first we read our frame. After that we can say here try, and we want to mention all these things. Let's just copy it from here, our file method, just paste it with open. This is what our file name, and now we want to only read our file. So we want to change the W with R for reading. Then all the things are same. Now we don't want to dump our points inside the Pickle file. Inside the file we want to load our coordinates. So Pickle dot load, and there is no need to mention points, we only want our file. So F, that's it. And then first when we start our code, it will check inside the file what is the coordinates, and then it will check that coordinates and it will draw with the help of points. We are drawing our coordinates using here, as you can see here. It will, when we start our code, we have here again the points, because this we want to mention points. As you can see, points is equal to Pickle dot load, and inside that we have our file. So when we start our code, it will check either there is points available or not inside our file. If there is a points, we can simply use for PTS in points, and we are going to draw the rectangle. Simple. Except, so here we want to mention except we are going to save the new coordinates with the help of our mouse L button down function. That's it. Now if I save the code, if I run the code, now if you draw here rectangle, and if you close the code and if you start the code, as you can see there is a rectangle, because we create a file with the help of Pickle and we are saving their coordinates inside our file. Not only we are saving the coordinates, also when we start our code, Pickle will load that particular rectangle coordinates. That's why we have already rectangle, because we draw the rectangle over here. So let's just draw all objects here also, here, here, here and here. Now just stop the code and run the code. As you can see, there is a rectangle already on each object. I hope you all clear. Now let's just say we want to delete the rectangle. Somehow we want to delete the rectangle. So how we can do this? For that we are going to create here new event, which is L button down for drawing the rectangle, R button down for deleting the rectangle. So let's just say here if event, copy it and paste it. If event, we are going to simply change L with R. R button down, a right button click from our mouse. After that, again we want to mention for I and PTS in enumerate, and inside that we want to mention our points. For I, PTS in enumerate, we want to mention our points, and then again X and Y is equal to PTS, because we mention here already XY, so this we want to mention X1 and Y1. X1 and Y1 is equal to PTS. Now we want to remove our points. When we click our R button down, simply we want to delete our rectangle. So simply we want to remove the points. So points dot pop, and we want to mention this I. That's it. Now if you save the code, if you run the code, R button down, CV2, okay, there is the if is not in a line, that's why indentation error. So simply save the code. If I run the code, now as you can see, if you press R button mouse right button, the rectangle is deleted, rectangle is deleted. Now simply draw here a rectangle and here, and now there is, from this bottle there is no rectangle. Just stop the code, run the code. As you can see, from this bottle there is no rectangle. So this is how you can use mouse event function L button down and right button down for drawing rectangle, also for removing, or we can say for deleting the rectangle. So let's just draw a rectangle, because we need a rectangle on each object. Here also, here also, here, here and here. That's it. So we have done with our rectangle. As you can see, we are successfully draw a rectangle on our frame. Done. We have done with test.py. So now we want to call our another file, which is test1.py. So let's just open test1.py. So open test1.py. So inside test1.py, same way, first we are going to only read our frame. So here I need to mention wait key 100, because the video is really short. So it will play slowly and it will play continuously, repeatedly. So this is what our video file. First, what we want here, we want to implement some image operation on our frame. So let's just say here we resize our frame. First we want to make our frame in gray format. So let's just say gray is equal to, gray is just a variable. So gray is equal to cv2.cvt color, cv2.cvt c color capital. As you can see, cv2.cvt c is capital color, and we want to mention our frame. We want to make our frame as a gray. So we want to call our frame, then cv2.color all the way capital color underscore bgr to gray. Now if we mention here our gray frame, our frame will be now become a gray format. As you can see, the frame is gray, there is no color. So after that we want to mention here a blur format. So frame blur is equal to cv2 dot Gaussian blur, Gaussian B capital, Gaussian blur. Flame blur is just a variable, and cv2 dot Gaussian blur, which we are going to use here, and inside that we want to mention our gray, because where we are going to mention our Gaussian blur function, we want to mention here on the gray frame. So mention the gray frame, then the coordinates 5, 5 and 1. Now if you go here and if you mention frame blur, the frame will become little bit blur. Okay, it will become a little bit blur. So here it is. As you can see, the frame is little bit blur. Now what we want to do, we want to use here a threshold function. So let's just say frame threshold is equal to, we are going to use here adaptive threshold function. So cv2 dot adaptive t capital threshold, cv2 dot adaptive threshold, and where we want to implement the adaptive threshold function, we want to implement on our frame blur. So we want to mention here frame blur. This is what our variable name, frame blur. Then we want to mention 255, and then cv2 dot all the way capital adaptive, then we want to cv2 dot adaptive, then we want to mention thresh, and then Gaussian C, cv2 dot adaptive thresh Gaussian C, then we want to mention cv2 dot thresh binary invert, cv2 thresh binary I and V, and then 105 and 9. So if we call our frame thresh threshold. This is what our variable. Just a minute, let's just copy as it is, copy it and paste. If I save the code, if I run the code, and as you can see, now we implement adaptive threshold function on our frame. That's why the frame is look like this way. There is a white and black color. Simple. Now we want to implement a median blur function. So let's just create frame median. Frame median, it is just a variable is equal to cv2 dot median b capital blur, cv2 dot median blur, and inside that we want to mention our frame threshold. So just copy it here and mention 5. And now if we call our frame, just copy and paste frame median variable, save the code, run the code, and as you can see there is no error. We are successfully playing our frame, means we successfully implement our median blur function. That's it. Now we want to mention here a kernel. So kernel is equal to np dot once, inside that we want to pass our values for kernel 3 and then np dot int 8, np dot int 8. Then we want to mention cv2 dot dilate function. So frame dilate is equal to cv2 dot dilate, and inside that we want to pass our frame median, copy and just paste it. Then we want to call our kernel, just mention comma, paste kernel, and then mention iterations. Iterations is equal to 1. Now if we call our frame dilate, let's just mention here frame dilate, copy it, save the code, run the code, and as you can see there is no error, means we successfully apply all the image operations on our frame. That's it, we have done. Now we want to crop our object, because we draw the rectangle on each object. So we want to crop our object with the help of our rectangle. So for that we want to call our file over here. So we have our file which is shelf. So just copy the file function and just paste it over here. Now we have our file. Now there is no need to mention try, because we have our file and inside that we have our coordinates. So we simply want to mention here with open, shelf is the file name, we are going to read the file and points, and with the help of pickle we are going to load our file. That's it, done. Now we want to create here a new function for cropping. So def crop, inside that pass the object which is f, means we are going to pass inside our frame. The cropping object is basically our frame. We are going to crop our frame. So f, and then what we want to mention again, we want to call our points, because we have here points. So we want to create here for loop. So for same way for pts in points, again we want to mention here x and y is equal to our pts, and we want our width and height. So just move inside our test.py, and where we have our width and height, so just copy it from here, and inside test1.py just paste it, let's say over here, after where we have our width open, here we have our width and height. So xy pts means we have xy coordinates. Now we want to let's just first draw our rectangle, then we will get the idea. So simply go here and copy and paste our function, copy it and just paste it over here, and let's just call our crop function. So here, after where we have frame dilate, crop, inside that we want to pass our frame dilate. So just copy the variable and just paste it. paste it, and here we want to mention our frame. Save the code, run the code, and as you can see, now we are running with test.1.py file. We are not run our test.py file. Test.py file is basically only for drawing rectangle, a rectangle management we can say. Now we are running test1.py and we create here crop function, and inside that crop function we mention our rectangle. So now with the help of test1.py we are drawing a rectangle. Simple. Now as I mentioned, if we want to implement what we create here, we create a image function. So we want to implement that function on our rectangle, means the rectangle is basically crop object, a crop frame. We want to pass out our all function on each rectangle. This is how we will get the idea. This is how we can say that particular in this rectangle what is the pixel value. If their pixel value change, we can say there is a space. If the pixel value is something, we can say there is no space. Simple. For that we want to crop all the rectangle. So now we can say here crop is equal to our object which is f, and inside that we have width and height, we have x and y. So simply y colon y plus height, then x colon width, sorry not width, x plus width. Crop is equal to f, our object, y colon y plus height, h, x colon x plus width means the w. Now we will get crop frame. So cv2.imshow str x multiplied by y and the crop. Now we will get the crop frames format. So if I save the code, if I run the code, as you can see, we have here a result for each rectangle. We are cropping each rectangle. Here it is, as you can see. So simply we successfully crop our object. Now what we are going to do? We want to count here a pixel. For that we have function. So now there is no need to show our cropping frame because we know what we have inside our crop. So now we want to count the pixel inside our cropping object, crop object. So for that we have function. So let's just create a new variable which is counter. Let's say not counter, let's say count, because after that we want to create here a counter variable. So let's just first create count. Count is equal to cv2 dot count non-zero, cv2 dot count, n is capital, z is capital, and inside that we want to pass our crop. It will count a pixel inside a crop frame. So now we want to put that values on our frame. So for that what we are going to do, we are going to use here put text rect method. cv2 dot put text. We are not going to use here a cv zone put text rect method. We are going to use OpenCV method cv2 dot put text, and where we want to put the text, we want to put the text on our frame. Then what else we want? We want our variable which we want to show our count. So mention string and the count variable. Then we want our xy coordinates. So mention x and y, and then we want to mention a scale for our text. Then we want to mention a font. So cv2 dot all the way capital font, Harshe plain font, Harshe plain, and then we want to mention the color. So let's make it a pink 255025, and let's say thickness 1. Now if you start the code, if I run the code, and as you can see, each crop rectangle we have pixel value. So watch for this rectangle because this rectangle will become empty. So if there is no object, when the person to count the object, there is 0. As you can see, right now there is a value, and now as you can see, when there is no object, there is a 0. There is 0. As you can see, there is 0. So simply we can say, we can mention here, where is our function here? So here we are drawing our, we are mentioning our pixel value on the rectangle. So after that, we want to create our condition. So let's just say if count, if it is greater than 100, then we want to make our rectangle green, because if the value is greater than 100, there is an object. So we want to make our rectangle green color. So let's just change our color red with green here. Let me show you. 255, 0, 255 and 0. It will become a green color rectangle, and else means if the value is greater than 100, if count is greater than 100, there is an object, the rectangle is green. Else means the value is less than 100, then we are going to make our rectangle red color, because there is no object here. And we are going to change our rectangle color with red. Now let's just freeze our frame, and we are going to check our result frame by frame. So as you can see, the pixel value just check for this object. So there is an object, the pixel value is 6423, and all others object values also, as you can see, there is a 4-digit pixel value. So let's just skip the frame when the person check out the object, and then as you can see, it's now decreasing. The pixel value is lower now, 1820, now it's 810, now is 0. And because we mentioned the condition, if the value is greater than 100, here the value is greater than 100, we have green color rectangle. If the value is less than 100, we have red color rectangle. It means there is a space, we have one space for this shelf. So now simply we are going to create here a counter. So not here, inside the function. So we have here our function. So let's say counter. When we start our code, we have counter 0, but when we have our condition match, else, here we want to say counter increase, counter is equal to +1, counter will be increased. And then here now we are going to use our CVZone put text rect method. CVZone dot put text rect. CVZone put text R is also capital, and then we want to put the text on our frame. Then we want to mention here text and our counter. So F in single quote like this way, and first we want to mention a text. We can say we want to mention the variable. So let's say space, S capital, space count, shift colon, and inside that we want to pass our counter here, counter. And then after quote we want to mention where we want to put our text, the coordinates 50, 60, and then we want to mention a rectangle size which is 2, and only one quote, rectangle size which is 2, and the text thickness size is also 2. Now if I save the code, if I run the code, and as you can see, we have a space count is the text, and we have counter. Now there is 0 space available. As you can see, we have green color rectangle on each object, but when there is one object removed from the shelf, we have one space, and as you can see, we have one. We counted, there is a one space. So let's just now start our frame in while loop with 100 wait key. 0, 1 space, red color rectangle. Again we are going to repeatedly play the playing frame. So red color rectangle and space count 1. So this is our friends, with the help of OpenCV we can create a space counter for shelf. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.